I'm gonna open a new instance of IDA, and now I'm gonna open this new guy that we just got here. Okay, says the same errors, but see guys, as soon as I load it, you can see right away that it has a lot of functions instead of just 2. You remember? And also all of them are pointing to UPX0, which is definitely good. You can even, if you go to the imports, you can see all the imports there. And even guys, if you try to, see if those are working properly, you can just go here and see if it is found by doing X, press the letter X, so that it can find the cross references, in other words, where this function is being called, and it found it. It's working pretty cool. So what's the problem? Let's put a breakpoint and start debugging it. Okay, so we do debugger, start process. Yes. So right away, when we run it, it says, hey, the instruction at this address, reference at here. So the memory could not be written. So this memory cannot be written. Is it because of permissions? If it is because it's unmapped, let's figure it out. So IDA takes us right to the place where was the issue. We can see here that RCX is being accessed and throw an error. What is RCX pointing to? So we can see that RCX here points to 7F F6 6B 6B 88. Okay, let's see where it is. So again, we go to 7F F6 6B. Okay, we say here 7F F6. Okay, F6, and then it says 6B. I don't see the 6B there. Let's go all the way down. No, obviously no. 7F F8, here is already over. We are looking for 7F F6. Okay, so here we have 7F F6. Okay, and then it says 06 here, and the RCX says 7F F6 6B. So here is 7F F6 0C, which is not in the range. The next one is 7F F6 06, is not there. All of those guys are 06 and end in 06, and this guy is 6B. As you can see guys, the next one goes to 7F F8. In other words, this address is not even mapped. Okay, it's not even mapped. Even well, it's enough. So it's not even mapped in memory. And why is not mapped in memory? The reason is called ASLR. As you remember, we're running on Windows 10, which basically means that ASLR is enabled. And also, the binary that we're analyzing has ASLR enabled. So it basically means that every time it's loaded, the address is changed. And since we dump it from a different process, it got the hard-coded addresses. When it's trying to access that old address, it is failing. So what we can do here, guys? So what we can do, let me just close this analysis. So what we can do, guys, or what we need to do is we need to disable ASLR. In order to do that, we're just gonna open the binary again. Here it is. We open it, and then, guys, if you remember the Windows binary class, in optional header we have what it is called DLL characteristics. If we click here, we can see multiple permissions. Image NX means basically that the stack cannot be executable. That's more for buffer overflow protection, stack overflows. We can see CH here, and we can see this guy, DLL can move. This is called also dynamic base. This is the ASLR. It's basically telling you that every time you run it, it will dynamically find a new address. That's also for avoiding exploitation attempts. So we're gonna disable this guy here, okay, and we save it, and we're gonna overwrite our original file. Now just let me clean quickly. I'm gonna remove these two guys that we created before, okay, and let's do the process again. I'm gonna do it faster this time because we already went through the whole process. So I open this guy, same errors, it is packed as you can see, and then I'm just gonna put a quick breakpoint here because I want to show you that now the base address should be always the same. So we're gonna run it on memory. Yes, it's running. Control S. We can see that the UPX points 0, the section 0 points to, actually easier, we can see that the base address is 14 million, whatever. It is just that address, always 14, right? Let's stop it. Stop it. It's not stop it, it's stop it. I'm practicing my accent, guys. I know you realize I'm American. Just kidding. It's my Mexican accent. Okay, so let's run it again. Boom. Okay, it's running. Control S. We can see that again it is being loaded every single time in the same memory base address. So that should be enough for us for this to work. So as I said, let me go quickly to the place where we already know is jumping to the import address table, which is jumping to the original entry point. Why did I say import address table? Maybe because it's 5 a.m. and I have not slept. Maybe that's the reason. Okay, so we said, oh sorry. Oh yeah, we said play. We reached there. F7. Yes. P to convert in function, space. So we're there. I'm gonna copy this new original entry point. We are gonna fire up our tool again. We find this our executable. Again, we place here our original entry point. Advanced search, yes. Get imports, all of them are there. We dump it. We fix it using the dumped one. It says, okay, now it saved it. Now let's test it. Again, we do Control Enter, pipe more, Control O to expand the window, and that's it, guys. So we get it unpacked. Okay, so basically what I show here, guys, is a basic packer, but the point here is the methodology that I want you to get. And then we follow the methodology, go quickly through the flow, find the dynamic calls, dump it, and obviously the ASLR thing that was not an issue in Windows XP back in the day, but now you need to take care of that. And finally, that's it. We're gonna be talking about more advanced packers, but it's important for us to always follow the methodology. See you in the next one.